This set of worksheets is on radioactivity, and we're going to start with the atom. It's very, very easy to look at an answer and think you know it. It's much more tricky to tackle a problem without any help and see how you do. And this is what I want you to do. You must have a go at the worksheet first, and then use this video to help you understand anything that you're struggling with. Don't forget, if you still don't understand it, you can use the question asker at any time, or you can ask me in class. Question number 1 is filling in this table. The proton has a charge of +1. We defined whatever the charge of the proton is, we're going to call that +1. And the same with the mass. Whatever the mass of the proton is, we're going to call it 1. Therefore, when you look at the neutron, that's got a charge of 0. It's neutral, so it has no charge, and it also has a mass of 1, which means it has exactly the same mass as a proton. The electron has a charge of -1, so it's negative, and we call it -1 because it has the same size charge as the proton, but just negative. But the mass is much, much lower. It's about 1/2000th of the mass of a proton, or specifically 1/1840th the mass of a proton. Question number 2. The sodium has 11 protons and 11 electrons. Now for an atom, these two numbers are always the same. And then the 23 represents the protons plus neutrons. And if we said that there were 11 protons in sodium, and the number of protons plus neutrons added up to 23, then the total number of neutrons must be 12. Question number 3. Why do atoms have the same number of protons and electrons? This is really important. The atom is overall neutral. It has no charge, and that's because it's got the same number of positives as negatives, the same number of protons as neutrons, and therefore the atom is overall neutral. Question 4 shows 2 diagrams of atoms that are isotopes of an element. Now, an isotope has a different number of neutrons, but if they're the same element, they must have the same number of protons. So, question A says, complete the labels W, X, Y, and Z. Now, W is the electron, because the electron flies around the outside, it orbits the nucleus. X is the nucleus. That's the bit in the middle that contains the protons and neutrons. Y is a proton. Now you know it's a proton because there are the same number of protons in both of these pictures. And if they're the same element, they must have the same number of protons. For example, all carbon atoms must have 6 protons in it. As soon as we change the proton number, it's not carbon anymore. The one thing that can change is the number of neutrons. And if the neutrons change, then it's not an atom anymore, it's called an isotope. Question Z is a neutron, and that's because you can see that there are 5 neutrons on the left-hand diagram and only 4 on the right-hand diagram, which means the number of neutrons has changed, which means this is an isotope. Question B. The nucleus is held together by a force that only has an effect inside the nucleus. This is called the strong nuclear force, or the nuclear strong force. Now it's called this because it's the strongest out of all the forces we know, and it acts inside the nucleus and it holds the nucleus together. Question C. What particles are affected by this force? It's only protons and neutrons. It only happens inside the nucleus. Question D is a bit harder. Explain why this force must exist to hold the atom together. So protons are positively charged, and all the protons inside the nucleus will repel as they have the same charge. So they should be pushing away from each other as much as they can. But they don't. They stay inside the nucleus. And this is because the strong force is there, which is attractive, and it pulls all of the neutrons and protons together in the nucleus. Now, the strong force must be stronger than the electrostatic force, because this is the name of the... This must be stronger, otherwise the nucleus would be pulled apart. Or pushed apart, I should say. Question E. The name of the force that causes the electron to be attracted to the nucleus is called the electrostatic force. This is the force that exists between positives and negatives, or the one that repels between positives and positives. Question F. If the proton and the electron are attracted, why doesn't it crash into the nucleus? That's because the electron travels in a circle around the outside of the nucleus, caused by the electrostatic force. Now, it's a bit similar to the moon going around the Earth. The moon is attracted through gravity to the Earth, but it doesn't crash into the Earth because it's going round in its circular motion. Question 5. An element is a single type of atom. Now, that doesn't mean it's a single atom, but only one type of atom is important. So if it only has carbon atoms, then it will be an element. As soon as it has some oxygen and carbon together, that's no longer an element. So that will either be a mixture or a compound. Question B. An ion is an atom with more or less electrons. And an isotope is an atom with more or less neutrons. Question 6. What happens to an atom if it loses a proton? It will change element. Now you can see this is worth 2 marks, so you need 2 points. It will change element because the proton number defines what the element is. As soon as carbon gains or loses a proton, then it's not carbon anymore. It's the proton number that defines the element. And we looked earlier and said the number of protons must equal the number of electrons because they must be neutral overall. Question 7. Look at these isotopes. Which two are isotopes of the same element? That's carbon 11 and carbon 12. Now we know they're isotopes and we know they're the same element because they've got the same name, carbon and carbon. Question B. Which two have the same number of particles in the nucleus? That's carbon 12 and and nitrogen 12. Now the 12 represents how many protons and neutrons there are in the nucleus. So carbon, there are 12, and nitrogen, there are 12. They have different mixtures, different combinations of protons and neutrons, but the total number in the nucleus is 12. Question C. Do any of them have identical nuclei? The answer is no. Carbon, boron, and nitrogen, they must have different numbers of protons because they have different names. So carbon, boron, nitrogen have different number of protons. Also, carbon 11 and carbon 12 must have different number of neutrons because they are isotopes of each other. Question D. How many protons in the nucleus of carbon 14? That has 6 protons. Now that's because it's carbon. Every carbon atom must have 6 protons. The same is with anything in the periodic table. The number that you see is the number of protons. The atomic number is the number of protons. And lastly, question E, how many neutrons in the nucleus of a carbon 14? The answer is 8. The 14 represents the total number of protons and neutrons in the nucleus. So therefore, 8 and 6 add up to 14. If you didn't want to listen to any of the explanation, you can just use these answers and mark your work. There's half here and half on the next slide. This is the last slide. You might want to pause it so you can use these answers to mark your work.